Okay, LT5 is apply the Pythagorean theorem to solve real-world problems in 2 and 3 dimensions. And in this video, we're just going to be looking at 2 dimensions. And later on in the unit, we'll look at some stuff with 3 dimensions. In the last lesson, we learned about the Pythagorean theorem, and we had 3 different ways to think about it. One of the equations was c squared is equal to a squared plus b squared. And then, okay, so this is if we were trying to find c, and remember the c side, or side C, is the side directly, diagonally, or opposite of the 90-degree angle. So if you want to find C, you add the squares of A and B together. But if you're trying to find one of the legs, one of those other sides, so A and B are those legs, for A squared, that's equal to C squared, the big side squared, minus the small side squared. And then B squared, the other leg, is just the same. It's C squared minus A squared. So these were the 3 different formulas we used to find missing lengths on a triangle. So we're going to apply these to some problems. So this first one, it says a 17-foot ladder is inclined on a wall as shown in the picture. It reaches 15 feet high. What is the approximate distance of its base from the wall? Well, the first thing we need to do is decide how these numbers factor in to our picture. Okay, so the 17-foot tall ladder. At first, it might seem like 17 is this length, but it's the ladder itself that's 17 feet. So this is 17 feet, and then it tells us that it reaches 15 feet high on the wall. So this side over here is 15.5. And we're trying to find the distance from the base to the wall. So we're trying to find this distance. I'm going to call it x. And we can use the Pythagorean theorem here because we're going to have a right angle where the wall meets the floor. That's going to be a right angle. Now what I like to do is just sketch the triangle like this, okay? So this is 15.5, this is 17, and this is x. All right, now the next thing I like to do is label A, B, and C. So across from the 90 degrees is the C, and then I'm going to call this one A and this one B. All right, so I'm trying to find B, so that means that B squared is equal to C squared minus A squared. So B squared is equal to 17 squared minus, and then A is 15.5. Okay, so 17 squared is 289. 15.5 squared is 240.25. And then once you subtract those, you end up with 48.75. And then to finish solving the equation, I take the square root of both sides. And, oops, there we go. So 48.75, the square root of that. I'm going to expect it to be very close to 7 since the square root of 49 is 7, and it is 6.98. So I'm going to say that B is approximately 6.98, and then we want a label on this one. These are all in feet, so this is approximately 6.98 feet, okay? And that's the distance it is away from the wall, and that looks reasonable with these dimensions right here. Okay, let's look at the next one. It says the size of a TV screen is reported as the length of its diagonal distance. A TV screen is 15.5 inches wide and 11 inches tall, so kind of a small TV screen. What is the approximate diagonal length of the monitor? Draw and label a diagram. Okay, so here's my TV screen, and it says it's 15.5 inches wide, and it's 11 inches tall, and it's asking me to find the approximate diagonal. Okay, so I'm going to draw that in. So this is what I'm trying to find. Okay, now I have a right triangle because we have this rectangle, and then I'm trying to find the diagonal. So I label my sides. Across from the 90 degrees is C, and then I'm going to call this side A and this side B. So this time, trying to find C, so my equation is C squared is equal to A squared plus B squared. All right, so C squared is equal to 15.5 squared plus 11 squared. 15.5 squared is 240.25. 11 squared is 121. So then C squared is equal to 361.25. And then I'm going to take the square root to find C. So C is approximately equal to 19.0065, so I'm just going to round that to 19. So it's about 19-inch TV is what they'd call that. All right. A tree makes a 6.2 meters long shadow. The distance from the tip of the tree to the tip of the shadow is 7.5 meters. Calculate the height of the tree. Now, they've already drawn a really nice diagram for us here, and we can see that this is 7.5, this is 6.2, and then this is what I'm trying to find, this height of the tree. Okay? Now, we have a right triangle because the tree is going to, we're going to assume that the tree is growing straight up from the ground. And what I'm going to do on this one is I think I'm just going to sketch a triangle without the picture over here. Okay? So that looks really horrible, actually. I'm going to fix that. Okay. There, that's better. So let's put the dimensions in. We know that this is 7.5, and this is 6.2, this is 90 degrees, and this is the one we're trying to find. So let's label the sides of the triangle. So across from the 90 degrees, that's my C. I'm going to label this side as the A, and this side as the B. So I'm trying to find B. So we know that B squared is equal to C squared minus A squared. So B squared is equal to 7.5 squared minus 6.2 squared. 7.5 squared is 56.25. 6.2 squared is 38.44. So that was B squared. And then when you subtract those, you end up with 17.81. Take the square root of both sides. So B is approximately equal to, did that on my calculator, approximately 4.2 meters tall. Okay, so let's look and see if that is reasonable. Yeah, 4.2 meters for this. If this is 6.2, that's certainly possible. Now notice when we're doing these contextual problems or these real-world problems, it's really important that we label because it's asking us a question, the approximate height of the tree. Well, the tree is 42 meters tall, about 4.2 meters. The TV screen is approximately 19 inches with its diagonal, and so on. So when you're solving those problems, make sure that you use labels.